Hello, Algebra 2. Today, we're still in section 5.2. This is lesson 8. Let's start with the warm-up. You may work with somebody if you'd like, or just try it on your own. But go ahead and pause the video. And try each of these 6 questions, and then afterwards, play the video, see how you did. You could even play just, question A if you're not sure what you're doing, and then try some of these on your own. Okay, so question A. Square root of 3 times square root of 12. That is the same thing as square root of 3 times 12, which is the square root of 36, which is 6. Question B. We've got the cube root of 5 times the cube root of 25. So we do cube root of 5 times 25, which at this point I could multiply it out, or I could just notice that 25 is 5 to the second, which if I'm multiplying a 5 with a 5 to the second, that's going to be 5 to the third. And then the cube root in the power gives me 5 to the 3 over 3, which is 5. Or I could multiply it out to get 125, cube root of 125. Question C. We've got the fourth root of 27 times the fourth root of 3. I'm going to do this one like question B. I think it's easier to use smaller numbers because I would have to multiply these, which isn't difficult. But 27 is 3 to the third, and 3 would be one more. So that gives us the fourth power of 3 to the 4, which is 3. Question D. We've got quotient, so I can do the square root of 98 over 2, which is the square root of 49, which is 7. Question E. I'm going to take this and rewrite it as the fourth root of 4 over 1024. And I'm going to divide those, and I'm going to get the fourth root of 1 over 256. So the fourth root of 1 and the fourth root of 256 separately is going to be 1 over 4. And then question F. Take the cube root of 625 over 5. And you could divide those. We'll get the cube root of 125 over 1, but I don't really need the 1. So the cube root of 125 is 5. So it's a quick review over square roots, cube roots, fourth roots. Here's a list if you need to reference it anytime that you're doing the notes or during your assignment. Hopefully we are starting to memorize these. Let me say that. All right, you really should start having a lot of these memorized. I might have mentioned this before, but for perfect squares, you should have all of these memorized. Cubes, I would say to here is a safe one to memorize, plus this one. And then for fourth, I would say this and that one for sure. So all of that. Okay. All right, so the lesson today, adding and subtracting, simplifying, radicals. If we add anything in math or subtract, we need like terms. We need to fix that handwriting. We need like terms. They have to be like. So that could mean all kinds of different things. Like with fractions, it would be common denominators. With like variables, it would be the same variable to the same power, 3x squared plus 5x squared. Over here, 1/3 plus 4/3 you could add together. And now with radicals, we have to have the same radicand. You have to have like radical. Oops. You have to have like radicals, which would be the same radicand. And what's a radicand? That is the thing underneath the square root. So we would need the same radicand to be able to add radicals, to add square roots or whatever root. So I guess I should say same radicand and same index number, which is the same root. So we've got to add this part the same as well. So we look at question A, and we've got the 4th root of 10 plus 7 4th root of 10. So what I'm saying is I have a 4th root of 10, one of them, plus 7 more 4th root of 10s. So total, I have 8 4th root of 10s. Question B, I've got 2 8 to the 1/5 plus 10 more 8 to the 1/5. So now I have 12 8 to the 1/5. Oops. There's another way of doing this. If you think about factoring, think about factoring out the GCF on this first one. I'll do it under here. On the first one, the GCF would be the 4th root of 10. And what I would have left over if I took out the 4th root of 10 is I would have 1 plus 7. And that's how I get my 8. For this one here, the GCF would be the 8 to the 1/5. So I would have that 8 to the 1/5 out front. And then inside the parentheses, I would have 2 plus 10, which is how I get 8. Nope, not 8, sorry, 12. I went the wrong way. 12, 8 to the 1/5. And we just rewrote it so the 8 to the 1/5 is second. So this is using the distributive property that we can do this. So we'll look at the next one. And every single term has a 4th root of 2x. So we can factor that out. When I factor that out, I have left over -3 plus 8 plus 4. Add that up. Let's see, it'll be 9. And then I will still have that 4th root of 2x. So another way, you could just read it saying we've got -3 of these things plus 8 of the same things plus 4 more of that same thing. Total, we have 9 of that same thing. So our next example, we've got 4 square root 3, 4 square root 2, and 6 square root 3. So the square root 3's would be like terms, like LL, like. So we can combine those, 4 plus 6, with that square root 3. plus 4 square root 2 is not like NL, not like. So I get 10 square root 3 plus 4 square root 2, and that's all I can do for that one. Question E. So none of these are like. But I happen to know that square root of 12 does simplify. Square root of 4 times square root of 3. 5 is still in front. So 5 times this becomes 2 times square root of 3. So this 5 square root of 12 is actually 10 square root 3. That middle term is still plus 2 square root 3. Now, because the 5 square root 12 was able to simplify, I wonder if square root of 48 can simplify. So I look for a perfect square that goes into 48, and 16 goes into 48. It actually goes in 3 times. And there is this minus 3 out front, and those are multiplied. So we've got minus 3 multiplied by 4 square root 3. So we've got minus 12 square root 3. Now we have the like terms for each of these. To add these together, I get 10 square root, no I don't. I get 12 square root 3 minus 12 square root 3. Looks like my answer is 0. Now, if I'm not sure if that's correct, I could check it on my calculator. I cannot check this one. Well, I mean, I can check that they're equivalent, but if I type this in the calculator, it's not going to give me that answer because your calculator will not give you square root of 3 answers. If I type this in the calculator, it could give me 0 as my answer if that is the correct answer. I'm just going to double check. I don't have my calculator on, so I'm just using my calculator right in front of me here. Sorry, I'm apologizing. I'm not doing it on the screen. But you saw me make a bunch of mistakes already, so we're going to find out if I made any mistakes on this one. Nope, the answer is 0, so I'm correct. Okay, the next one, I look at both of these, and they are not like, but perhaps 54 could simplify. 54 is, oh, these are cubes. So 54, I know is 9 times 6, but those aren't cubes. But if I move a 3 over to here, I could get 27 times 2. So cube root 27, cube root 2. The cube root of 27 is 3. So we have 3 cube root 2 minus cube root 2. So that gives me 3 minus 1, cube root 2, 2, cube root 2. So all I have for you to check on the calculator at this point, here, why don't I open up my calculator? Take me 1 second. Okay, so to check that, I would type in cube root of 54. So to get the cube root, you go to the math button, and then there's my cube root option number 4. And then I'm going to type in 54. Then I'm going to arrow over so I'm not under the cube root anymore. And then I'm going to subtract. Was it subtract? It was subtract, wasn't it? Double check real fast here. It was, yep, subtract. We're going to go back to math. And then 4. And I'm doing the cube root of 2, and I get an answer. Now, that does not tell me the answer that I got. So in order to check it on your calculator, we're now going to type in 2 cube root 2, 2 cube root 2. And now we can see that both decimals are equivalent. So at least I know that I didn't mess up royally because these are equivalent answers. All right, multiplying, then adding, subtracting, like radicals and roots. Remember, when we have squared, we're going to write it twice. So I wrote it twice. And this does not look like a 5, so I'm fixing that. A little bit better. And then you can either distribute, or you can make one of those box grid things. 2 square root 5 minus y. 2 square root 5 minus y. Since I'm doing this and I didn't have a lot of space, I'm going to zoom in big time so I have enough space to write. Okay, when I multiply 2 times 2 and square root of 5 times square root of 5, I get 4 times square root of 5 times square root of 5 is 5. So I get 20 for that spot. This one right here is going to be negative 2y square root 5. This one right here is going to be negative 2y square root 5. And then negative y times negative y is positive y squared. So I will have 20 minus 2y square root 5 minus 2y square root 5 plus y squared. We're going to add like radicals. They both have square root 5. They both have a y. So we're just going to add the numbers in front. So I've got a negative 2 and a negative 2. 20 minus 4y square root 5 plus y squared. Remember, when you add y plus y, that does not change the exponent. That's only when you multiply. It also doesn't change the like term. So I'm really just adding the negative 2 times negative 2. All right, question B. I'm going to distribute because I've got a binomial on the inside and one on the outside. So you can distribute, or you could make a grid if you want. I'm not going to do the grid for this one, but you could do square root of 2, 5 square root of 3, 3 square root of 6. You could do it with a grid. When I multiply these together, I'm only multiplying things that are in the same location. So square root of 2 and square root of 3. So that would be like 5 multiplied by square root of 2 times 3 plus 3 multiplied by 6 times 2, square root of 6 times 2. So I get 5 square root 6 plus, and that's going to be 3 square root 12. But as soon as I see that square root 12, I have to factor out that square root 4, which becomes a 2, and this 3 is in front. So I get a total of 5 square root 6 plus 6 square root 3. These do not have like radicals, so they just stay apart. Okay, so this is student practice. This would be a great time to pause the video, see if you can do these, and then check your answers with my work. Okay, question A. 4th root of 27. I'm going to make this a little bit easier on myself, and I'm going to make 27 into 3 to the 3rd, multiplied by the 4th root of 3. If I multiply those together, I get the 4th root of 3 to the 4th, which is 3. This next one, I'm going to take the 3rd root of 250 divided by 2, which is the 3rd root of 125, which is 5. All right, cube root of 104. So I'm going to look for a perfect cube that goes into 104. I'm thinking 8 does. I think 8. Let me see if 8 goes into 10. That'll be remainder. Okay, 8 goes in 1, 3, 13 times. I'm sorry, I had to stop for a second because my cat is on my desk eating my snack. She's licking it. All right, temporary delay. Sorry about that. Okay, so now we've got the cube root of 8, which is 3, and then cube root of 13, I can't do anything. Oh my gosh, the cube root of 8 is not 3. Get distracted by the cat, sorry. Okay, sorry. You see how I just made that silly mistake? This would be a good time for us to just show again how we can check our answers with the calc. Cube root of 104. So I'm going to go math 4 and then 104. And I did 4.7 something. So now I'm going to check that with my answer, which was 2 cube root. And I had 13. Let's see if that is correct. And they come up with the same decimal. So this is not going to tell me that it's simplified all the way, but it does tell me that I'm not wrong. All right. We've got 4 9 to the 2/3 with plus 8 more 9 to the 2/3. So I've got 4 plus 8, 9 to the 2/3. So I have 12 9 to the 2/3. I wonder if there would be any reason to simplify this. So 9 to the 2/3 would be the third root of 9 squared, which is the third root of 81. Now 81 is 27 times 3. Or it's 3 to the 4th. We could go either way here. 27 times 3. So cube root of 27 is 3. And then I have cube root of 3. So this would simplify to be 3 times 3 to the 1/3. Now if I go back up, there's a 12 in front of that. I could simplify this further to 36 times 3 and 1/3. Kind of depends what the directions say, but this is a more simplified answer. So let's check that with the calculator. Looks like check. What was our original was 4 times 9 to the 2/3 and 8 times 9 to the 2/3. Okay. 4 parenthesis 9 caret alpha y equals 2 over, oopsies, 2 over 3. So I've got 4 times 9 to the 2/3. And then what's that? And that was plus. We've got 8 parenthesis 9 caret alpha y equals, enter, 2 over 3. So just typing in the original, I get 51.92. Then we thought the answer was 12, or at least I thought, I'm over here by myself, times 9 alpha y equals, enter, to the 2/3. Oopsies, what happened here? Okay, so 9 alpha y equals, enter. Oh, why does it keep doing that? 12 parenthesis 9. Oh, because I didn't hit 2 that, I think. There we go. Alpha y equals, enter, 2 over 3. Okay. So we know that that answer is correct. And then let me just check my last answer that I got when I went and simplified it a little bit further. 36 times 3 to the 1/3. Let's see if that one works. I really don't know. I'm just trying it for the first time. 3 caret 1 over 3. Oops, that did not work. I forgot to make it a fraction. Oh my gosh. 36 parenthesis 3 caret alpha y equals, enter, 1 over 3, enter. There we go. So I did simplify it correctly. So when you use your calculator to check, it's only going to be able to check that these are equivalent. It's not going to really tell you if you've simplified it far enough. It's only going to check that they are equivalent. Okay, where are we here? 2 more examples. Okay. Got 7 times the 5th root of 12 minus the 5th root of 12. So if I say I've got 7 of these and I take away one of them, then I will have 6 5th root of 12s. There is not a 5th root that goes into 12, so I can't simplify that. And then this one here, perhaps let's break down cube root of 40. I know 8 goes into 40 5 times. So I've got the 5th root of 5 plus 2 third root. I'm sorry. I'm saying the wrong thing. You guys, I apologize. I'm saying wrong things because I'm kind of tired. 3rd root of 5 plus 2 3rd root of 5, which gives me a total of 3 3rd root of 5s. Okay, so that is lesson 8. And you have a worksheet to complete. Have a great day.